This video is going to show you how to work through the Lego modeling of our muscles and what happens in our cells. The first thing that you have to model is our glucose. And so we have our three different atoms. We have our carbon, which are black, hydrogen, white, and oxygen, red. In our glucose molecule, we know that we have 6 carbon. So I'm going to take these 6 and I'm going to put them over here where I'm going to build. I'm just going to connect them together however I feel like connecting them together, just so they are touching, because we know that they should be connected together in the molecule. Okay. Your model does not have to look exactly like mine, as long as you have the right number. So then we know that we should have 12 hydrogens in our glucose. So I'm going to count out 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to put those onto my molecule as well. Again, it does not matter how they are attached, just as long as they are attached. So those are 12 hydrogens. And then we know that we should have 6 oxygens, which are red. So I'm going to count out 6 of these. 1, 2, 3, 4, 5, 6. And then again, attach them wherever they can be attached. So this is our glucose molecule. We have 6 carbons, we have 12 hydrogens, and we have 6 oxygens. What we are going to do with the rest of our oxygens is we are going to make O2 molecules or oxygen molecules. So we are going to put 2 of the oxygens together. And then looking at this, we were able to make 6 oxygen molecules. The next thing that it asks you to do is look at our model of carbon dioxide, count the molecules that are in there. So you're going to tell me how many carbons, how many oxygens, and hydrogens are in that diagram. And then number 4 says carefully disassemble all the molecules that you just built, the 1 glucose molecule, and the 6 oxygen molecules back into individual atoms. So we talked about how these are our inputs to our body. So we took these into our body, and we talked about how our body needs to break all the big molecules down. So we are going to break these down so we have these atoms to work with. So we're just going to break everything apart, because once we have molecules in our system, they need to be broken down so they can be rearranged and made into what we need for our cells. And then it says using only the carbon and oxygen atoms, build as many carbon dioxide molecules as possible. Remember, our carbons are our black and our oxygens are the red. So I'm going to put all the hydrogens to the side right now. And based on the model that's in our packet, we know that carbon dioxide has 1 carbon and 2 oxygens. So I'm going to put 2 oxygens onto each of these carbons. And yours don't have to look like mine. I did mine like this so we can still see the carbon underneath. So we were able to make 6 molecules of carbon dioxide. 1, 2, 3, 4, 5, 6. And we have some leftover atoms. So leftover oxygen, we have 1, 2, 3, 4, 5, 6 oxygen left over. We still have our 12, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. We have 0 carbons left over. So now we are going to use these to make a water molecule. The first thing you need to do, though, is look at your diagram, count the number of atoms, how many carbons, how many oxygen, and how many hydrogens are in the water molecule. we can see that each water molecule is made of one hydrogen, one oxygen and two hydrogen. So we are going to put those together. Actually, we'll do it like this. So that is going to be one water molecule. We are going to use the remaining of our bricks to make as many water molecules as possible. Okay. So if we count them, we were able to make 1, 2, 3, 4, 5, 6 remaining water molecules. So our outputs, what we ended up with was 6 water and 6 carbon dioxide. Remember, we started with 1 glucose, 6 oxygen, and then our body broke it down, reused it, made it into our outputs, our waste molecules of 6 water and 6 carbon dioxide. The last thing that you need to do is answer the 3 analysis questions on the back page, and then you are done.